Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. Since you already know that we are doing our statistics paper 2, solving the PYQ, and in very detail we are doing it, and we are taking it very slowly, even though some of you who are clear in their concepts might be seeing our videos as very slow, but this video is not only for you, but it is also for the ones who have just begun their preparation for the ISS examination in the upcoming future. So considering all the students or all the aspirants of ISS examination, we are providing this video to you. In order to get the video, if you are clear with the concepts and you know where to arrive and how to attempt the questions, so you can see the video lecture in 1.5 times speed in the YouTube. And those who haven't done anything yet, they can watch it at its own pace. And this will be helpful for all those who have already given the paper, this year's paper, and the ones who are preparing for giving it in the future. So let us begin. Till now, we have done question number 61 to 80, which were of official statistics from 1 to 10, 11 to 20, and 21 to 30. All of these question series are completed. Those who haven't watched it yet, it is uploaded on our channel. You can watch it now or after watching this video. And today we will be considering the next 10 questions, which is from question number 31 to 40. So let us begin. Again, I'm telling you that we are taking series A. If you haven't done if you have got another part of the series, the number might be differ from the question we are doing, but the question will be exactly the same that has been given here. So only the number will be shuffled. So the first question here of question number 31. One more thing, in this series we are not considering part 1, 2 and 3 of every question series, but we have considered in solving of paper 1. This trick you can use to solve the paper in the examination hall. That will save your time and will also give you time for revision of the questions that you have not attempted. Everything will be managed following that series. So this first question is of SPRT, sequential probability ratio method. This is our question number 31. Now we all know that sequential probability ratio method terminates with probability 1. This has already been given. And the condition, there are three conditions of sequential probability ratio method. When A is less than equal to 1 minus beta upon alpha, when X is greater than equal to A, when X is less than equal to B, and when X lies between A and B. These are the three conditions that should be fulfilled. And one more thing, A is equals to 1 minus beta upon alpha and B is equals to beta upon 1 minus alpha. So considering these situations, in question number 31, there are two situations that have been given to us. A is less than 1 minus beta upon alpha and B is greater than 1 minus beta upon 1 minus alpha. So the code given below, which of the following are correct? So both 1 and 2 are correct, and hence option number C, which is both 1 and 2, is the correct option for this question. The ones who have read even once about the SPRT ratio or SPRT method, then they would have solved this question within no time. Now moving towards question number 32. Question number 32 talks about maximum likelihood estimators. Under maximum likelihood estimator, we all know that the estimators are unbiased, follow normal distribution or normal, we can say, and efficient, most efficient among other estimators. So these are the three things that are asymptotically true about maximum likelihood estimator, and hence option number D, which says that all the three options are correct, 1, 2 and 3, is the correct answer for this question number 32. Now moving towards our question number 33. Many of you would have confused it. It was direct implementation of the theorem that gives us. So first of all, let me tell you, if we talk about any estimator T, then variance of T. If T, suppose T is an estimator of gamma theta. So we can say that expectation of T can be written as gamma theta. Okay, if it is an unbiased estimator, variance of T can be written as expectation of T minus gamma theta whole square. Okay, and if we are talking about bias of T, then this is nothing but expectation over theta of T minus gamma theta. Now, if we see our first statement, it clearly gives us that variance of gamma theta, variance of T is equals to variance over theta of T plus bias of T whole square. Or here in place of variance of T, we can write it is M.Sc of T, which means mean square error. Mean square error of T. This also can be written as, instead of variance, this also can be written as the formula for mean square error of T. Okay. So this is the formula, and by comparing these formula with this, equation 1 correctly states this formula, and hence equation 1 is the correct statement that has been given. Then second statement gives us the bias of T. Now bias of T, we have already put it here. Let us take this as second statement and instead of this. So bias of T is expectation over theta of T minus gamma theta, and hence our statement 2 is also correct. This is just the formula for our mean square error, variance and bias, the relationship between these three terms of an estimator. So we are given here that. So hence we can say that both of these are correct, and hence our option number C, which states that both 1 and 2 are correct, is the correct option for question number 33. Now moving forward with question number 34. Here again, they have asked us to calculate the sufficient estimator and maximum likelihood estimator. First of all, by following Fisher-Neyman factorization theorem, we will be calculating sufficient statistic. So fx theta has already been given to us as theta x raised to the power theta minus 1. If we take likelihood of this, it will be theta raised to the power n, I goes from 1 to n, summation xi raised to the power theta minus 1. This will be the likelihood if we sum over n. Okay. So here, from comparing this with Fisher-Neyman factorization theorem, this we have done multiple number of times. If you haven't watched the previous videos, then you can watch the lecture. I'm not explaining it again in detail. I'm just putting the final values here. So it will be our Tx, which is the sufficient statistic. So if you see clearly, equation 1 states that summation over I goes from 1 to n, xi is the sufficient estimator of theta. That equation is correct. So we can write that equation 1 is the correct equation for this. Then the second statement, then the second thing that we have to follow is maximum likelihood estimator. For maximum likelihood estimator, we have to consider this. We have to differentiate L with respect to theta. If we do this, First of all, we have to take log of L. Log of L, which will be n log of theta plus theta minus 1 summation log of xi. I goes from 1 to n. Under log, multiplication term changes into summation. Okay. Now following this, we will be getting differentiating this log of L with respect to theta. It will be n by theta, and if we consider this, it will be plus summation over xi. I goes from 1 to n log of xi. Okay. Now if we put it equal to 0, then our final answer will be n by theta is equals to minus summation I goes from 1 to n log of xi. And if we find the value of theta cap, which is the maximum likelihood estimator of theta, it will be minus n upon summation I goes from 1 to n log of xi. This is as easy as this, and hence our equation number 3, if you see, it is also correct. And equation number 2 is not correct because it is not the sufficient statistic. So we can conclude that equation 1 and 3 are the correct equations till now. Let us see if there is another equation given in the question. So there is no other equation given in the question, and we have to select the code for the correct answer. So 1 and 3 is option number B, which is the correct option for this question number 34. I hope that it is clear. We are taking it very slow. So moving towards another question, which is again statement based. Maximum number of questions that has been asked over the years in statistics paper 2 is about the theorems, statements and everything. So it is very much important that instead of just practicing numericals, you should follow practicing the theoretical portions very deeply and understanding the very basic level. If you just mug it up, it is not going to help in the examination, neither in the numerical portion nor in the theoretical portion. So doing the conceptual, having the conceptual knowledge is very important in statistics paper 2. So here, in question number 35, they have given us the variance. V is an unbiased estimator of gamma theta, and T is the sufficient statistics of gamma theta. And phi t has been given to us, which is expectation of V given T is equals to T. First of all, they have given us that phi t is an unbiased estimator of gamma theta. If we consider this, phi t is an unbiased estimator of gamma theta. If we take expectation of phi t, then we will be taking expectation over iterated value. So it will be double expectation of V given T is equals to T. And the final answer will be expectation over V, which is nothing but gamma theta. So hence our equation number 1 is the correct equation, which states that phi t is an unbiased estimator of gamma theta. It is the expectation over iterated values, the theorem that is used here. Now the second statement says that the variance of phi t is less than or equal to variance of V. If we consider here the variance of phi t, it is equals to variance of T V plus variance of T. And from this statement, you can say that variance of phi t from here, let us take variance of V. Variance of V have the formula variance of phi t plus variance of V given T. This is the final formula for variances of calculating phi t. So from here only, from the statement only, you can consider that variance of phi t is less than variance of V, and hence this statement 2 is also the correct statement. Now the third statement that has been given to us. It says that phi t is a function of sufficient statistics which is dependent on theta. Whenever there is a function of sufficient statistic, it should always be independent of theta instead of dependent on theta. And hence our statement 3 is wrong statement. So, and the conclusion points will be statement 1 and 2, which is option number C. That only statement 1 and 2 are the correct statements for this question. Now moving towards our question number 36. They have given us that xi follows normal distribution with mean mu and variance sigma square. Mu lies between minus infinity and sigma square is greater than 0. That both mean mu and sigma square are unknown. Which of the following statements are correct? So first of all, there we know that whenever mu and sigma square are unknown, then the maximum likelihood estimator of mu will always come out to be x bar, and maximum likelihood estimator of sigma square will always be come out to be 1 upon n summation I goes from 1 to n xi minus x bar whole square. So considering this, equation 1 is the correct statement as I can see from here. Equation 2 is not, because the capital S square has been given the maximum likelihood estimator, which is not the correct one. Now, if we see here that if we take the expectation of sigma square cap, then it doesn't come out to be sigma square. But if we take the expectation of capital S square, then it comes out to be capital S square. So, hence we can say that S square is the unbiased estimator of sigma square, S square is the unbiased estimator of sigma square instead of sigma cap square. So hence our equation number 4 is correct and 3 is wrong by this method. So let us see which 1 and 4 are the correct option, which is option number D. 1 and 4 are the correct options for this question. Now moving towards another question. This question is very interesting one, question number 37. It was very easy, but it was made to come in the examination just so as to confuse you, and many would have been confused by this. The basic concept asked here is that if efficiency of T1 upon T2 has the formula variance over theta T2 upon variance over theta T1. This is the formula. Now we have done it various number of times, that if variance of T2 is less than variance of T1, then the least variance have the maximum efficiency. But it becomes opposite in efficiency terms. So it when I say that T2 is more, T2 is, what do we say? T2 is more efficient than T1, and here it will be opposite, that efficiency over theta T1 upon T2 is less than 1. So efficiency of T1 is less than efficiency of T2, which means that T2 is more efficient than T1. So from here, if we see statement number A, which gives us efficiency of T1 upon T2 is greater than 1. They have given us greater than 1, which implies that efficiency of T1 is more efficient than T2, because T2 will go on the right side. Let us do it. E theta T1 is greater than E theta T2. From here only we can say that T1 is more efficient than T2 because it has greater sign, and hence equation number A is the correct answer, which is Option number A of question number 37. Very interesting topic, very easy topic, just a little bit of understanding and you would have solved it. Now, question number 38. Here we have been given uh, a PDF of a uniform distribution. F x alpha beta is equals to 1 upon beta minus alpha. Okay, they have given us, and the values of x lies between alpha and beta. So we have to find the maximum likelihood. First of all, to calculate maximum likelihood, we have to calculate L, and L will be summation over this, which will be 1 minus beta upon alpha raised to the power n. Now to maximize this L, if we have to maximize this L, then we have to minimize this term so that it will be maximized, right? Now we know that alpha lies between, if we take ordered statistic, if I am taking ordered statistics of all the xi's, then the maximum value alpha can take is x1 and the minimum value beta can take is xn. Okay, this is proved from this one. Now to maximize this, beta should be maximum. To maximize beta minus alpha, beta should be minimum and alpha should be maximum. So that we get the answer as to minimize the denominator and to maximize the L. But beta can only take value, the least value that beta can take is xn and the maximum value that alpha can take is x1. So MLE, when we consider a uniform distribution, if you have read clearly about uniform distribution, then it is always said that alpha and beta takes the value x1 and xn, which are the ordered estimate, and hence option C is the correct option in this question, where we take x1 and xn as the values of alpha and beta respectively, which is also the MLEs of alpha and beta. I hope that I was able to tell you the concept behind this. If you still didn't understand, you can comment down below and we'll be taking one whole class over this concept. Now, question number 39. It was also an easy topic, just the definition. So, there are three types of resampling method. There are many types, but we will be discussing only three types of resampling method. One is bootstrap, then is jackknife, other one is cross validation. These are the methods of resampling, and stratified sampling is not a method of resampling, it is a method of original sampling. And hence the how many of above are resampling methods? Three, which is option number C is the correct option. That three methods are the methods of resampling from the given above four methods. Okay. Now moving towards पेपर टू नीचे इकोनॉमिक्स का बढ़ गया ये तो हो गया था।
नहीं अपने हाथ से शिफ्ट कर दो 45 कहाँ है?
ये रहा।
मूविंग फॉरवर्ड कर दो ना।
Now moving forward to next question, which is our last question for the day. Question number 40. Question number 40 has stated us, given us that the critical region W and the consequently test for testing or null hypothesis versus alternative hypothesis is unbiased if the null, when we test H naught versus H1, it is always said that the power should be greater than the size for the test to be unbiased. This is the important concept that we have discussed in the discussion of PYQ series of our courses as well. And this has been repeated many number of times in your PYQs. So the option number, the power can be represented as probability that X belongs to the critical region given H1 is greater than or equal to probability X belongs to the critical region given H naught. The one that satisfies this, if we see it this clearly, the one that satisfies it is option number A. The power is greater than or greater than or equal to the size of the test. So this was all that we had to do in today's lecture. I hope that you understood it very well. If not, you can comment down below wherever you are facing any doubt. We'll be helping you solving in those, and we are taking it at a very slow pace for all of you to understand it very nicely. Even if you are facing doubts, you can ask us anytime in the comments or on our WhatsApp channel. And all the best. Thank you.
Welcome to StatUp Academy, India's exclusive coaching for ISS, where statistics meets excellence. StatUp Academy,